Hello, my name is Darren Thomas, and I'm the Director of Educational Research Techniques. And we are now in Unit 3, Lesson 4. And we've been looking at ridge regression. And so now we're finally going to take a look at how to deal with testing our model and to see how it is doing. So why don't we go ahead and get started. So I'm in RStudio now. And so again, I've said this several times, this information in lines 1 and 2 is just to get the packages going. Line 3, again, the data set should already be in R for you. If not, you can always use line 3 to get that going again. And we want to set our seed to 1, 2, 3 again. Now, in line 6, this is something we could have did way back in almost like the second lesson where we were doing our data preparation. We're going to make our test matrix. In other words, we're going to take the data from our test set, and what we're going to do is that we're going to strip out the dependent variable, which is, of course, blood pressure in our situation, and we just want the independent variables. That's what we're going to do. So we're going to take a look at that now. We're going to do that. So we're taking variables 2 through 10 because the very first variable is blood pressure. We don't want that in our test set. Now, in our second line here, we're going to make an object called ridge.y. And what we're going to do is we're going to use the predict function, like so. And we're going to use our ridge, our ridge object. We made that in the previous video. And so what we're going to do now is we're going to take that model that we made and we're going to use it to predict new values based on this thing right here, our test matrix. Test.matrix. Remember, we just made this in line 6. And we want the response. That's what we want. That's the argument we have to set. And of course, if you see here, this is so important. I'm going to zoom in because I want to make sure this is clear. Notice that we set S, which is for the lambda. I don't know why they call it S, but S is set to 0.63. We got this value from the previous video. S is an example of what we call a hyperparameter. It is a parameter that you, as the researcher, as a data scientist, must set yourself, because the algorithm cannot figure out what value to set this to. So we set it right here to 0.63, and we learned that in the previous video. That's what we did. Now, having done all that, we can go ahead and create our object now, and it's done. Now, in line number 8, we're going to take a picture of it, and what we're going to do now is that we basically made our model. If you actually looked at it, I guess we could do that real quick. Ridge.y. It's not that exciting. They just give you a potential blood pressure value for each person. That's all that's happening right here. For each person in the test.matrix object. Now we can plot this, and what we're going to do is this. We're going to plot the ridge value, and we're going to compare it to the actual value of the test blood pressure. Remember, we removed this when we made the test.matrix because you don't want the dependent values in there because the computer doesn't have to predict anything. So let's see here. And so this is a visual of kind of what's happening. So we have a general trend that as the predictions for ridge.y go up, the predictions that are in the test blood pressure also go up. Now, it doesn't really matter which value you put as the independent or dependent. That's not the point here, because either way you're going to get the similar picture. But we do have a general direction. It's not perfect. You can see there's a lot of problems here. And we can also add the line by using the values in the code in line 9. And so this is the code right here. Again, this is not a data visualization class, so I'm not going to focus too much on how to teach that. But you can see that there's clearly some sort of a slope here. But this is visual. So how good is the correlation between these two? This is where we're kind of assessing the strength of our model. How is it doing? How good is it, etc. And so you can also calculate the correlation, 0.4 here. So as ridge goes up 1 unit, blood pressure goes up 0.4 units. Again, is that good or bad? You cannot tell the strength of a model unless you are able to compare it to other models. So if we really wanted to see how well we are doing, we would have to make other models, either manipulating the lambda, manipulating some sort of other hyperparameter, or using other algorithms and then calculating the metric as well. That is how you can be clearly convinced of what is the strongest or the weakest model based on comparison and not on some sort of an absolute standard. So right now the correlation, this is what we have. This is, I guess you could say, our baseline. We would have to make other models to see how we're doing. And for the final model that we can make, first in line 12, we take the residuals. So we take ridge.y, the ridge predictions, and we subtract them from the actual grounded truth values, if you will, to get the residuals. And then we square those. So these are like the mean square error, or the mean square residuals. And we get this value of 409. This value of 409 does not mean anything unless it is used in comparison to another model. That's kind of what's happening. Generally, the lower the error, the better the model, but lower error depends on what that model is being compared to. So this is kind of our baseline. And if you're really exploring, really trying to generate a strong model, we would, like I told you already several times, manipulate the lambda, make models with other algorithms, etc., and try to see which one gives us the lowest mean square error, which one gives us the highest correlations between the grounded truth and the predicted values, etc. All that is the fun of data science. So in this video, we actually completed the process of making a model from start to finish using ridge regression. And so what we did here was not that complicated. We, of course, created a test dot matrix to have our independent variables separated from the dependent variable in our test data set. We did our prediction in line 7, and then we started to judge our model. We look at the plot. This is right here to your right. We added a regression line here, and then we also calculate the correlation, which is this value right here down below. After that, the last trick that we did was we found out what the residuals were, and we squared those to see what our mean squared error was. And again, this value for the mean squared error is only useful in comparing this model to other models. There's no cutoff points for excellent or bad in this particular context. So I hope that this was useful for you. My name is Darren Thomas. I am the Director of Educational Research Techniques, and this is simpler, practical application of machine learning algorithms in R. Thank you.